All right, number 4 is a classic AP problem because they're going to ask you about a resonance structure here. So first of all, it says to draw the Lewis dot structure for ozone. So ozone, O3, is 18 valence electrons. So if we throw down with some oxygens here and then make everybody happy on the outside like normal, that is just 16 electrons, and we have 18. So one set goes here in the middle like so. But now we have used all our electrons and we don't have enough, so what do? We take one of the lone pairs and we turn it into a multiple bond, but we now have identical terminal atoms, oxygen and oxygen, and they are bonded differently, and so consequently this is really a resonance structure. So it could be that, or it could be this as its Lewis dot structure. Which one is it? And the answer is neither of them. So remember that this looks like a double, and that looks like a single. This looks like a single, and that looks like a double, when in point of fact that neither of that is true. This is really a 1.5 bond. That is really a 1.5 bond. This is really, again, a 3/2 or 1.5 bond. 1.5 bond. So each of these guys is a 1.5 bond. It's just that the Lewis dot structure idea can't account for this. So what have I got here? I want to know what the bond energy is in ozone. So knowing that these are actually identical, then this is actually X and X, or X and X, depending on which way you want to do it. And so now what we've got is our reaction where we're going to have 2X for the ozone. And again, there's no bond here. That's just a single oxygen. And then we're going to subtract from that 2 times 498. Where in the heck did 498 come from? That's this guy. They're telling you what the bond energy is in oxygen. And then all of that equals a total of negative 394 kilojoules per mole. So knowing that it's 2X, whether you choose left or right, doesn't matter. You go through and you solve for X, and you're getting X to be equal to about 301 kilojoules per mole once you actually solve for it.